Welcome back everyone. Hello, welcome back everyone. Hi. Please say hello, hi, something. Am I audible to you? Is the screen visible to you people? Hello. Okay, this is audible now. Okay. Okay, thank you. Actually, that is not visible at in my mobile. Okay, let me proceed. Okay, thank you. Okay, we were on the question of shuffled anagram. What is shuffled anagram is we need to take a string as input and we need to shuffle the string in such a way that for example, let me shuffle the strings and make a new string like for example like this, and I need to shuffle in such a way that I need to shuffle the characters in such a way that at every index the characters do not match. See, A and C are not matching, B and A are not matching, C and B are not matching, means this is the shuffled anagram. According to the question, this is the shuffled anagram. Okay, anagram means anagrams, actually anagrams, if you check out the English meaning of that, means changing the position of these characters. But according to shuffled anagram according to question is which is satisfying this condition, means at every index the character should not match. So that's the problem, that's it, this is the problem. Actually I don't know why they provide this much lengthy problem statement. So you can this is the problem statement, one line. Okay, and what is the output they want? They want one shuffled anagram as a output. Okay, this is one. There may be many shuffled anagram possible. Actually I can shuffle the characters in many ways. Okay, and but we need to print one only. Okay, and one more thing, if we are not able to print the if we are not able to generate the shuffled anagram, if we are not able to generate such type of shuffled anagram, then we need to print this, we need to print impossible. For example, okay, can you make a shuffled anagram for this string? Please write in the live chat if you can make a shuffled anagram for this string. This is my input string, please give me a shuffled anagram for AAB. Anybody, please write in the chat. I'm waiting for you people. Please reply so that we can connect with each other. Okay, Abhishek is written that okay, no anagram, shuffled anagram is possible for this string. Why that is not possible, we will discuss that thing later. Okay, actually we will definitely we will discuss this point. This is very important point. But one thing is clear right now, I need to print impossible. I need to print in impossible for this string because I cannot generate a shuffled anagram for this string. Okay, let me try for this. Maybe I'm writing B first, then I'm writing AA. But okay, here these two are not matching, but this is matching. This A and this A is matching, even though this is also not matching, but one character is matching. That's enough to that enough to prove this. Okay, I can say that, okay, this is not the shuffled anagram. Okay, that's it. Actually, for this string I cannot generate. Okay, let me take more example. For this example, okay, let's suppose I have this string kick. This is the string given in the question itself. Okay, I have a string kick, kick. Can you people find out which one is the shuffled anagram out of these three? Out of these three, first one is this, second one is this, third one is this. Can you people tell me? Okay, can you people tell me, is this the right shuffled anagram, or the second one is the right, or third one is the right? Which one is the right one? Please write in the chat. Which one is the right one? Which one is the right shuffled anagram here? Out of these three, 1, 2, 3. Out of these three, which one is the right shuffled anagram? Which is the shuffled anagram actually? This is our string kick. Four characters are there in this string. Okay, and I am trying to generate 3 different anagrams. But which one is the right one according to this condition actually? According to this condition. Okay, which one is the right one? First one is the right one. Yes, first one is the right one. And Dheeraj says that, okay, that is third one. Third one is I don't know. You are talking about. I think third one is the wrong one actually. Third one is not the shuffled anagram according to this condition. Otherwise, first and second are, you are right. First and second is the shuffled anagram. Okay, means you understand the problem. What is problem? What is the problem? You understand it completely. Yes, these are the shuffled anagram, but this is not. Why this is not the shuffled anagram? Because this k is matching with this k. This is our old string. This is our new string. At any position, any character should not match. Even this k is also matching. See. But this k is not matching here and here, not matching here and here. This I is not matching here and here. This C is not matching here and here. This K is not matching here and here. So these two, first and second are the shuffled anagram. Yes, these are the shuffled anagram. We need to print one only actually. But this is not the shuffled anagram because K and K is matching. That should not match. Okay, you understand the problem, what the problem is. Okay, let's move on. Let's check out the solutions for this. Let's take the first solution. Let me apply the brute force approach. First of all, let me apply the brute force approach to solve this problem, the problem of shuffled anagram. Okay, according to brute force approach, okay, let me sharing you what comes in my mind first time. We can try every permutation of all the characters in the string actually. We can try all the permutations. For example, okay, let me give you an example. Okay, let's suppose this is our string ABC. This is our input string. In how many way I can, okay, how many permutations I can make? This much permutations I can make. Okay, I can write ABC. I can write it like A, then C, then B, or maybe like B, A, then C, or maybe C, B, C, A, and so on. Actually, in permutation, you can say that, okay, you have fixed the A. Here, I have fixed the A, and I change the position of B and C. I fix the B, I change the position of A and C. I fix the C, I change the position of B and C. So, important part here is that I am able to make six permutations here. Okay. Otherwise, you can also apply the formula for that. What is the formula of permutation? Let me write here. That is n fact. If I am finding for NCR, that will be n factorial divided by n minus r factorial. So that is actually here number of character I am selecting is n itself. So that will be n factorial divided by n minus n factorial. So this will be actually 1, and what I will get, n factorial. So this much number of permutations I can make out of a string. So here the length of the string is 3. So I can make 3 factorial combinations. So that is actually 3 into 2, that is 6 combinations I can make. Yes, 6 strings I can generate, 6 anagrams I can generate. Okay, by using the so after generating these anagrams, now I can check which one is satisfying this condition. What condition? This one. We need to check this condition actually. The old string index, any value at any index in old string should not match with new string. This is our condition. We know that. This was the condition given in the question. Okay. Can you people tell me? Okay. Can you people tell me out of these 6 combinations, which one is the shuffled anagram? Shuffled anagrams follow this condition. We know shuffled anagram follow this condition. This is our input string. This is our input string, and these are the different permutations we can make with these 3 characters actually. Okay. So which one is the right shuffled anagram which satisfying this condition? 1, 2, 3, 4, 5, 6 out of 6. Please write in the. Okay. Already get the answer. Dheeraj says 3, 4, 5 is the right shuffled anagram. These are the right shuffled anagram. Let me check. 3. You are saying 3. Let me check. Let me compare A. Okay. Let me rub the board first. Let me rub the board. Okay. So you are saying 3rd, 4th and 5th are the shuffled anagram which we are looking for. Okay. So let me compare. A is, let me compare it. Let me use the pen. Let me use the pen. Okay. Okay. So let me compare A and B. That is not matching. Very good. B and C. Oh, sorry. B and A not matching. Very good. C and C, that is matching. That is matching. So this is not the shuffled anagram. Why? Because C and C are matching. Let me check 3rd, 4th and 5th also. A and B not matching. Very good. That should not match. B and C not matching. Very good. C and A not matching. Very good. Okay, this is the shuffled anagram. Let me compare this one also. A and C not matching. Very good. B and A not matching. C and B not matching. Very good. So this is also a shuffled anagram. And let me check other also. What about this? This will definitely not match. This is A and A is matching. Okay, I was comparing here. Actually, this is the same. This will not match. This is the same as string, and this A is matching. So this will not also match. Here you can see. Okay, B is also matching. B matching here. So this is also not the shuffled anagram. So here 4th and 5th are the shuffled anagram actually. So how this algorithm is working, how this brute force algorithm is working, I will make all the possible permutations first, and then I will find out which one is satisfying my condition. Which condition? All string index value should not match the new string index value. So I will generate all the strings to generate all the strings I need to make the complexity will be order of n factorial, because these are n factorial combinations. These are n factorial different sequences I am generating, n factorial. We know this thing. So to generate all these, the time complexity will be n factorial. After that I am searching over that. So even that, to check every string, again that will take n factorial. So total complexity will be n factorial. For this algorithm, to find out the shuffled anagram, the complexity will be n factorial, and that is the very worst actually complexity. Okay, so let's see whether we can improve over it or not. We can improve the complexity or not. Let's see. Okay, let's move on. Okay, let me go about the concepts. See, concepts are more important. How actually algorithm is working, you can implement in any language, in whatever you want. You may be comfortable with C, C++, Java, and whatever you are comfortable, you can continue with that. Let's first discuss about the different approaches, how we can solve these problems. Okay, that will be easier to understand for us. Otherwise, you can on your programming other programming skills. Programming skills means you can learn any particular language and you can implement that. That is the second task. First, very important task is how you are solving the problem. Okay, what is your approach to solve the problem? If you want to go into the Google, they are not binding you for any language. They are not binding you for C, C++, Java, whatever Python you can use any language. But the important part is which approach you are using to solve the problem. Whether you are using brute force approach or you are using any other approach. Okay, let's check all the different approaches to solve the same problem. The same problem we will solve with different approaches. Then we will be able to understand, okay, how we can improve the algorithm. Even in the interview, if you can explain the logic, okay, you can explain the logic, okay, I will solve the problem like this, they will hire you. But if you are using brute force approach to solve a problem, definitely you are not going to be hired even by other companies also. Okay, so going through all these approaches will help you to understand how you can improve. Okay, let's take another question here related to the shuffled anagram. This one is the very important question actually related to this problem. What this question says is, how you can make sure that shuffled anagram cannot be created from the input string. Okay, I have an input string like this. Some of you people were saying that, okay sir, we cannot create the shuffled anagram from this string. So actually, how you can make sure this thing? How you can make sure this thing? Please, anybody write in the chat. How even some give the solution that, okay, for this particular string, some of you give the solution that, okay, this is we cannot generate the shuffled anagram for this string. Some of you give the solution for this, but how you are saying that, okay, we cannot generate the shuffled anagram for this string? Are you just you were applying brute force approach, means you were checking every combination, or is there any way also to find out that, okay, for any string of any length you can say that, okay, do this thing, and from that step we can find out that, okay, whether we can generate or not a shuffled anagram. Okay, if we cannot generate, we know that we need to print impossible. We need to print the impossible. Okay, when you can say that, I'm repeating the question, when you can say that we cannot generate the shuffled anagram for a string? Because one of the answer is just because same character index is same. Okay, when we create a new string, so the question is, okay, Aniket, you are right. If frequency of any character is more than half of the length, yeah, that is the right answer actually. If frequency of any character, let me read what he have written. If the frequency of any character, let me take the character A. The frequency of any character is more than half the length. Okay, it's if I divide it, length of this string is 3, divided with 2, I make it half, and I get 1. So the number of characters A here is 2. So 2 is greater than 1. So if 2 is greater than 1, then we can say that, okay, we cannot generate anagram from this. Yes, you are right. Your solution is applying here. Let me write the solution here itself. So solution is, if a character exists more than, okay, lower bound of n by 2 times then it is impossible to generate the shuffled anagram. Why this solution is working? Let me take an example and explain to you people. See, in this string, the length of the string is 5, and if we divide it with 2, 5 is the length, 1 2 3 4 5. If divide with 2, then I get, okay, let me take the lower bound. So lower bound is 2. So if any character, because a is repeating many times, so I am taking a. See, a, the frequency of a is 3. The frequency of a is 3. So if this is frequency of any character is more than this value, then I can say that I cannot generate shuffled anagram for this string. I cannot generate shuffled anagram for this string. Yes, I cannot generate shuffled anagram for this string and for this string. If any character is more than, if frequency of any character is more than the lower bound of n by 2, then I can say that, okay, that we cannot generate the any shuffled anagram for this particular string. Okay, let's move on. So we will use this concept. We will use this concept in our next approach, in our next algorithm. Let's see the next algorithm. This is halting, I don't know. Let me. The screen goes halt. Can you please put your social media for any clarification in problems? Okay, you can post your problem in the comments. I will try to solve your problem there. You can post your problems in the comment. Okay, and let me move this screen. Okay, I don't know, this moves many times. This system is hanging, I think. Please allow me to repeat, okay, to restart this this particular PPT. I am just restarting this particular PPT. Okay, I am restarting it. That will be better. So let me close it, this thing also, and let me reopen the PPT. So we have already gone through this, and we have taken this example, and now we are on this solution, second solution. In second solution, actually we will use our previous concept. What concept? Means okay, when we can say that, okay, we cannot generate the shuffled anagram for our input string. Okay, we know in what condition we can say this thing. So we will use that concept here itself. Okay, let's solve the same problem. Let me share the second solution for the same problem. Shuffled anagram, same problem, second solution. This is the actually these are the steps in the second solution. This is the algorithm for the second solution. Okay, and this is our input string. I will take an example. I have taken this as an input string, and I will apply the second solution, means this algorithm over this string, and we will try to find out the shuffled anagram. Okay, let's directly apply these steps. Then we will see actually, okay, what these steps are doing. Okay, let's apply these steps one by one. Okay, one by one. Let's start with the first step. Even string. We have this is our input string. This is our input string A C B C B C. Okay, and we will sort the letters in descending order. Okay, so here alphabetically, if you will see, C, this is the largest one, C is the largest one. So let me write C first, all the three C. I am sorting the letters alphabetically actually. After that B will come, B, 2B are here. After that one A is there. Okay, I have sorted, simple. I applied the first step, that's it. Let's apply the second step, very easy. That is also very easy. Split the array into half. Okay, so we have 6 characters here, 1 2 3 4 5 6. So 3 and 3 will be the by dividing them into 3 we can divide it into half, means half elements will going to the left and half element in the right sub array, half element in the left sub array. Okay, simply I split the array into 2 half. 3 elements go this side, 3 element goes this side. Let me apply the third step now, last step. Okay, place the second half, this is the second half, this is the second half. Place the second half element corresponding to first half, this is the first half, into the original string. Okay, I need to place the second half element into the original string based upon the first half. Okay, what this statement is doing it, let me write it here. Let me explain this by writing here. First of all, one thing is clear, we need to make changes in the original string now. We need to make changes in the original string. So let me copy the original string. Whatever was my input, let me copy that. Okay, let me copy. So A, C, B, C, B and C. So this is my original string, and according to this statement, I need to make changes in the original string. Okay, so what this statement is saying, second half, place the second half elements. I need to place these elements in my original string based upon the first half elements. How? See, I will place the B element corresponding to C in the original string. So I will place B in place of C. Okay, I will repeat this step again for every letter, actually for every character I will repeat. Now let me place this character. So B, corresponding letter for B is this C. So I will place B in place of C in my original string. I will repeat this step again and again for every character. Okay, for A, corresponding character is C in the first half. So I will place A below C in my original string. That's it. This is what this statement is saying. Okay, and we need to do it both sides, vice versa, from left to right also, from the first half to the second half also. I have put all the elements of the second half. See, all the element of second half. Let me put all the elements of first half also. Same procedure. So this is the first element, and I will put the C below B in my original array. I will put this C below B in my original array. Same step is repeating. I am taking C. See, I am repeating same step. I will repeat. This is the one character I get. I relate it into the second array. So corresponding letter to this C is A. So I will place this C in original string below A. So here is A. So I put C in place of A. Okay, you can cut these also. Okay, so this is that's it. Our algorithm ends here. So we get our shuffled anagram. Please check if this is the shuffled anagram or not. Please check. See, A and C are not matching, C and B are not matching, B and C are not matching, C and B are not matching, B and C are not matching, C and A are not matching. They are not matching. That's good. This is our condition. That should not match. Means this is the right shuffled anagram. So this algorithm generates our right shuffled anagram. Okay, if you still have doubt in this, how this step is working, I will repeat this step also in the next slide. Okay, by making little modification in the input. I will change the input. I will take another example. Don't worry. Okay, before that, can you people tell me? What is the main key idea working behind this algorithm? Okay, you have algorithm with you. I have written the algorithm in try to write the algorithm in very easy language. I'm not writing it into the code. I'm writing that in English form so that you can understand. Okay. So can you people tell me actually what this solution is actually trying to do? How that is getting the right answer? How that is able to generate the shuffled anagram from this input? How that is able to generate that thing? Actually, what's the logic? What is the main key logic he is applying? So this is the algorithm with you. Anybody, please try it. See, the only thing to learn here is that how to solve these problems. You need to think over that. You need to think how to think. That's the main point. You need to think how to think. Okay. So you have algorithm with you. This algorithm is giving right answer, giving us the shuffled anagram. But what actually this algorithm is doing? Actually, what is the logic he is applying? What he is trying to do? Can you find the intuition behind this algorithm? Anybody? Anybody, please. Anything, you write anything. Please write anything. How we get the shuffled anagram? Okay, let me share the answer with you, and let me share the key ideas with you people. This is the key idea. Can you people tell me, okay, is this key idea is right or wrong? Yes or no? Yes or no? Is this the same? These three steps are doing this thing only. That is working due to this thing only. Actually, this person who solved this problem like this, who generate this algorithm, actually he is trying to do this thing only. He is taking benefit of this thing. Is this right or wrong? Yes or no? Please, yes or no? Second array is not very good. Kaushik, very good. Second array is not equal to first array. Always the elements in second array will not be equal to the first array. Okay. But there is one exception we will cover in the next PPT. Okay, just there is one exception. Otherwise, you are saying very right. No letter in the second half is overlapping here. In this case, no letter in the second half is overlapping. See here, B, B, A we have. Here, C, C, C we have. So, we have 2B here. These 2B are overlapping here in the second half. They are not in the first half. Okay. And similarly here, this C, C, C are overlapping here in the first half, but there is no C in the second half. And due to that only, we are not replacing any C with any other C actually. We are not replacing any C with any other C. Or we are not replacing any B with any other B, because we are replacing them based upon each other. This is replacing based upon, first is replacing based upon second is replacing based upon first. Okay, and because there is nothing common in between them, so definitely they will, these two things will not match. These two will not match. So this is the key idea actually behind working behind this algorithm. Okay, let me take one more question, one more example. Now in the previous, I'm working on second solution itself. Second solution I'm working on, the same algorithm I'm using, same key point is here. Okay. Same solution I'm using, but I have changed the input. Now the input string is of odd length. Earlier you maybe noted that the string was of even length. 6 characters were there. Here we have 1, 2, 3, 4, 5, 6, 7. We have 7 characters. For 7 characters, actually how this algorithm will work. See how this will work. Let me apply all the steps. So we need to sort the elements. If you don't understand, okay, how this algorithm is working, I'm repeating that thing. For this input, for odd string, little bit change will be there. Okay, how this algorithm will handle odd string. See, sort the element in descending order. Sort them in descending order. Okay, I'm writing descending order means C is repeating. C is the biggest one alphabetically. So I'm writing C first, then B, and then 3 times C, and then 2 times B, and then after that A or D. I can write okay, I need to sort them in descending order. So D will first come, D will come, then C, then B, and then A. Okay, I have sorted it. Okay, I have sorted it. Now let's split the array into two half. Okay, here we have 7 elements, so we can put like this, 4 element at one side, left side, and 3 element at right side, or 3 element at the left side, 4 element at the right side. You can divide it in any way. Okay, let me divide it like this. 3 element at the left hand side. Intentionally I am dividing so that I can show you one thing, and 4 elements at the right hand side. Okay, and after that we will apply this thing, but before applying this step, you may note that okay, something is matching here. C is matching here, C is matching here, but according to our key point, that should not match. Okay, that should not match, but still this algorithm will work because that is an exception. Okay, that is exception for odd string, and even for odd string, even though that is matching, but this algorithm will work. Let's see, let's apply this step and see okay whether we are getting the right shuffled anagram or not. Whether we are getting right shuffled anagram or not. Let me apply the same step. If you are not able to understand this step earlier, I am doing the same thing. Okay, so we need the original string. So this is our original string. I am copying it here from here to here because I need to make changes in the original string. I am just simply copying all the elements of original string. Okay, done. Now see what this step is saying. Simple. Okay, take one element from second half, compare, okay, find out its corresponding element in first half, and whatever is the corresponding element, check out this element in the original string and put this C below that. Okay, same step. Now take next element and find out its corresponding element in first part, that is C, and again put this element below C. Take next one, B, put below C, next C is here. Okay, next A. See, up to here we have done, so this A will go below this C. We have put C below D, this B below C, this B below this C. So we have one extra element, because we have one extra element, we have one extra element in the right half because we have done it in this way. So this element will be put here. Okay, so this is the exception. We will put this element here below C, because up to here we have already processed. We have already replaced these elements. So next element to replace is this C. So I will put A below C. C must be in the original string. So C is here. I put A here. Okay. So this was from right to left. Let's apply the same from left to right. Okay. From left to right, D below C. Okay. Not from below C, because we have already processed C. We have already put A below C. Next one, D below B now. D below B. D below B. So this is the B. Next one, C. C corresponding element is this B. So I will put C below B in the original string. Okay, and this C below A. Okay, this C below A. So I get this shuffled anagram, and let me check, is this working fine or not. They should not match. B and C are not matching, B and D are not matching, C and B are not matching, B and C are not matching, C and A are not matching, D and C are not matching. Okay, they are not matching. So this is the right shuffled anagram. This is the right shuffled anagram. So our algorithm is also working fine on the old string by making little exceptions. Okay, earlier we were saying that there is no overlapping element, but in the case of odd there may be one element. There may be one element as a overlapping. There may be one element, not more than one. There cannot be more than one. There you cannot say that okay, 2C will be here and 2C will be here. This cannot be possible. This cannot be possible. I cannot have 2C here. If I will be having 2C here, then there will be overlap. Definitely there will be overlap. There will be no 2C here. You cannot, can you give me any input string in which 2C will be at the right hand side and 2C at the left hand side? Can you give me? Please type in the live chat. Can you people, anybody, can you give me any string in which if I divide them, if I sort them and then divide them in two halves, then these 2C match with these 2C, means I have a 2C here. I cannot have 2C here. Can you change it somehow? One of my student in earlier class, actually, he changed this B, actually he changed this B into C, and he is saying that, okay sir, now I have changed this B into C, now I will get 2C here because I will sort it like this. See, let me do it. Let me rub the board. Okay, that is, let me use the eraser. That is not working. Let me erase all. That is also not working. That's fine. Okay, let me replace the B with C. Now this is my input string, let's suppose. Let me apply the first step. So this will be D, then C, C, 1, 2, 3, 4. 4C will come, and after that 1B is there and 1A is there. Okay, and we have divided in two half. See, 2C are here, 2C are here. Now if you can see, C will go below D, this C will go below C, this C will go below C. There will be overlap. There will be overlap in the final answer because this C is going below C. So if this algorithm fails, can anybody tell me? Can anybody tell me, okay, why there cannot be 4C here? Why there cannot be 4C? I cannot have 4C in this input actually. He replaced the B with C. Okay, now I have 4C, 1, 2, 3, 4, but I cannot have 4C in my input. Why I cannot have 4C in my input? Anybody please reply. Why I cannot have 4C in my this input? Anybody please write in the live chat. Anybody, why I cannot have 4C in this input? If I have 4C in this input, definitely my algorithm will fail. Definitely C will go down, or C will be below the C. So there will be, so they both will match, and that will not be a shuffled anagram, and algorithm will fail. But I am saying that, okay, I cannot put 4C in this. Why I cannot put? Because as it Utkarsh, because sir, it overlap each other. Yes, that overlap, that is overlapping. If that is overlapping, then our algorithm will fail. I am just applying this algorithm, these three statements. This is our algorithm. I am applying these three statements, and that I cannot change these three statements. That is the algorithm. And if I am applying this algorithm, they are overlapping. And if I am getting overlapping, the algorithm will fail. But algorithm will not fail. Why? Because I am saying that I cannot put 4C in the input string. I cannot put 4C in the input string. Why I cannot put 4C in the input string? This is my question. Why I cannot put 4C in the input string? Impossible. Very good. Kaushik, impossible. The answer is impossible. And Rahul is saying, in that case, shifted anagram is not possible. Very good, Rahul. Utkarsh, it will overlap with each other. Okay, if we split 4 and 3, Mitali, 4 and 3, then answer change. Okay, Rahul and Kaushik, you are very right. I cannot put 4C because if I am putting 4C here, then actually I will quote this condition earlier than this. How I will quote? Because this string will be, I will generate the output as a impossible. Why I will generate output as impossible? Because you people know that if I am having any character in my input whose frequency is more than the length of this, if the frequency of any character, in this case I'm talking about C, what is the frequency of C? Frequency of C, if I am putting 4, that will be more than, you can check, that will be more than, what is the n value? 7 characters are here, 7 characters are here, 7 by 2, lower bound will be 3. Yes, this condition is satisfying. Because this condition is satisfying, this code will not execute. I will not execute this code. I will simply print. I cannot generate shuffled anagram from here, from this string. I cannot generate. Okay, I cannot generate shuffled anagram from this string. Why? Because of this condition. Because the number of C now exceeds this term. If number of any character, not about C only, if any character exceeds this term, I can simply say I cannot generate shuffled anagram from that. We have already discussed this thing. Okay. So this is the second solution. We have applied it over the even string as well as odd string. Let's calculate its complexity. How much time this algorithm is taking? You people please tell me. Okay, how much time this first step is taking? Please tell me. Please write in the chat. How much time this first step is taking? Anybody, please. Okay, Cyber, you said the same thing, Cyber Nation. Okay, very good. Because character cannot greater than n by 2. Very good, very good, Cyber Nation. Okay, anybody, please tell me how much time this step will take to execute. I need to sort the element. How much? What is the complexity to sort the elements? I want to sort the elements. So that will be, okay, Kaushik says order of n. So which algorithm you will apply? Kaushik and Nation, which algorithm you will apply to sort the elements so that you get order of n complexity? Which algorithm you are applying to in sorting? Please share the algorithm also. If you are using comparison based sorting, if any comparison based sorting, selection, bubble, merge, heap, quick, any of the comparison based sorting algorithm you are using, so even in the if you are using, okay, then the complexity that will take is actually order of n log n. Okay, but you are saying, okay, order of n. So please tell me, okay, you are using a sky value. Okay, Cyber Nation saying n square. Okay, better than n square, we can apply maybe a merge sort here, we can apply quick sort here, we can apply heap sort here to get the elements, our element gets sorted. Okay, so we can apply this algorithm. Okay, let's suppose we are applying quick sort here. For right now we are applying quick sort here. Quick sort is one of the best algorithm, one of the practically best algorithm, okay, used in industry actually to sort the elements. Okay, so let me apply that, and the complexity is n log n. And what is the complexity of this second step? Okay, I will come at this point again later on, at the end actually I will come at this point again, but right now I am applying quick sort, which is one of the best practical algorithms. So that the complexity is n log n in best and average case. Worst case actually very rarely will happen if all the elements are already sorted. Okay, so I am applying, let's suppose, quick sort, or maybe you can say merge sort. In merge sort every case is having n log n complexity. So I am sorting the element, okay, using merge sort. So the complexity is n log n. Here, what is the complexity? Splitting the array in two parts. Okay, we will come, Cyber Nation, we will come at this point. This is merge sort versus quick sort. That is another topic. Otherwise, quick sort is practical. I have already said that is the practically most practically that will take less time as compared to merge sort even practically, because you are not comparing, see, you are not comparing the right side elements. We divide that in two parts in quicksort, and we do not compare the right side elements with the left side elements. We do not compare in quicksort, but in merge sort we compare left side element with the right side element with the left side element. If you are making more comparison, definitely that will take more time. But in quicksort we do not compare. Okay, that is different topic, we will talk about that later. You can write in comment. And second step will take actually constant time. We are dividing in two parts. We are saying okay, actually we are not putting the elements into two array. We are just saying that okay, we are saying okay, the n by 2th location, this location is the middle location of the array. Okay, so element from 0 to, I can say okay, up to n by 2 is in first part, and after that upper bound n by 2 to up to the end in the second part. Okay, so I'm just to divide means we get the middle element index for that, so that I can get in order of one time. Okay, and what about this one? This step is taking how much time? Anybody? Third step, what we are doing here, picking one element from second part, comparing with the left part, corresponding element in left part, and putting in original array. Okay, so actually we already if we use the array with its index, okay, we are storing an index also with the character. With every character we have the index of that character. Then we can store every character in constant time. Okay, we can store every character in the constant time. So this is, let's suppose this is our string A, B, C, D, E, F. This is my original array. Okay, I'm replacing here actually. I'm replacing in place of A, I'm replacing maybe B. In place of B, I'm replacing A. Whatever I'm doing. So I'm doing in this step. So I'm storing with my array, I'm storing its index location also. Okay, let's suppose this is 1, 2, 3, 4, 5, 6. So directly I can go to that location. I can directly go to that location and I can change that actually. I can change that. Okay, so what I mean to say that for one character to change one character, that will take order of one time, constant time. But I am changing how many characters? N characters. N is the length of the string. So I am changing n characters, so that will take order of n time. Okay, you can give more time over thinking over it. You can, if you are not able to understand, please give little more time. Definitely that will be clear to you. Otherwise, the concept is that to replace one element, constant time will take. To replace n elements, n time will take. Total order of n time will take. Sorry. So what is the total complexity? Total complexity, let me write. This order of n log n plus order of 1 plus order of n. So what is total complexity? Total complexity of second algorithm is order of n log n. Get from here. Okay. And if you don't know about the complexity, you need to read the data structure and algorithm. Okay, let's move on. Let's move to the third solution. Same problem, third solution. Same problem, third solution. This is different algorithm from that. See, solving the same problem with different approaches, learning this thing is very important. We want to reduce the complexity. Earlier in the first solution, the complexity was n factorial. We reduce it to order of n log n. Let's see whether we can still reduce it or not. I have another solution, third solution for the same problem. Okay, let me take an example and apply this all steps of the algorithm over this example, over this string. I will convert this into the shuffled anagram string. So very easy. This is very easy actually. First step is saying that find the frequency of all the letters in the string. What is the frequency? Okay, you people tell me. What is the frequency of A? How many times A is repeating? One time. How many times B is repeating? B? Two times. How many times C is repeating? See, 3 times. How many times D is repeating? 1 time. So first step completed, that's it, according to third solution, third algorithm. Second step, sort the letter in descending order in order of their frequency. Okay, frequency of A is 1, frequency of B is 2, frequency of C is 3, frequency of D is 1. Frequency means how many times that letter is repeating. So according to based upon frequency, sort them, that's it. So in descending order actually. So biggest one will come first. So C, first C will come. Let me write in the form of a grid. Actually C will come, then after that, okay, B having the largest frequency. After that A and D both have same frequency. You can write anyone at any place. Either you can write D, A also. So I have sorted them. I have simply sorted them. That's it. Second step completed. Third step, replace the letter J with letter I in the original string. We have already done this thing. We are changing in the original string. We have done this thing in second solution also, but a little bit change here. What we are doing is, let me explain this with the help of this example itself. But one important thing here is that we need to replace a letter J, any letter J, with any letter I, such that this condition hold. This thing is important. That's it. I will use this condition. Okay, so frequency of J, we know the frequency of every element, and we have sorted them also according to their frequency. We know that C is having highest frequency, B is second most, A is third most, and after that D. We know based upon the frequency, okay, I can compare this condition. I will use this condition and I will apply the third step. Okay, let me apply. In this example, this will be easy to understand. Okay, so I need to make changes into the original string. So let me copy the original string here. A, C, B, C, B, C, D. I copy it because I am going to change in the original string, similar to string 2, similar to solution 2. Okay. Okay. Now, according to second step, I need to replace letter J with letter I such that frequency of letter J is greater than letter I. See, what I will do here is, B is having less frequency than C. First of all, okay, what we will do in this is, okay, let me start the third step. In the third step, what you will do is, you will place the elements in place of C first. Wherever C is there in the original string, you will replace that first. First you will replace C. C is occurring 3 times, so you will place everywhere C. Then after that you will replace B. After that you will replace A. After that you will replace D. We need to place all of them such that the character should not match. Okay, that thing will be taken care by the algorithm itself. We will just follow this algorithm. He is saying that, okay, what he is saying that, take B first. We need to place, according to this step, we need to place B in place of C in original string. We need to place B in place of C. So let me put first. In place of B, C, I put B. In place of C, I put B. Actually, I have 2B only. I have 2B, so I left with 0B now. So for 2C, I put the B. Why I put B? Because B is having less frequency than C, because that is satisfying this condition. C is having higher frequency than B. C's frequency is 3 and B frequency is 2. So that's why I am putting B. Okay, that's why I am putting B below in place of C. But I have only 2B. So that's why I am able to replace only 2C, but I have one more C. So for that, again, A is having less frequency than C. So I can put A here. So number of element left with A is 0 now. Earlier we have one frequency of A. So I put that in place of C now. So I have consumed B as well as A, both of them, to replace the C. Okay, and this step will repeat again and again actually. See, now we have done with C. We have replaced all the C. and now we will replace b. We will replace b in the original string. How? With whom I will replace b? Who is having less frequency than b according to this step? Who is having less frequency than b? Who is having less frequency than b? One is a, one is d. But a we have already consumed. We have already put a. The value of a is 0 now. The frequency of a is 0 now. So what is left with us? D. So I will put d in place of b. So this is our b. I put d here. But we have one more b. But we have one more b. So in that case, actually I have consumed this also. I have consumed d also. I have consumed all of them. What is left with us? Only the first element. In sorted array, we left with only first element. So that is the exception actually. If that happens, if only first element left, all I have consumed, then simply replace remaining letters with first letter. Replace remaining, whatever is remaining, A, B and D is remaining, replace that with C, with first letter. This is the first in sorted array. Replace this with C, 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 that's it. This is, I am not doing it from myself. This is what this algorithm is doing. I am just following this algorithm, that's it. Okay, let's see, okay, whether we get the right anagram or not. This is the shuffled anagram which we were expecting or not. A and C are not matching, C and B are not matching, B and D are not matching, C and B are not matching, B and C are not matching, this is also not matching, not matching. Yes, this is the right shuffle anagram. We get the right answer from this algorithm. Can you people tell me what is the logic, what is the key idea, what is the intuition this algorithm is applying so that we are getting the right answer? If you can think over that, that is the main job. That is, you need to think at the time of this Google KickStart round. At that moment of time, first you need to strike that point. Then only you will be able to develop this algorithm. And after that you can write the code. Please, if anybody can from these algorithm, if if you can tell me, okay, what actually this solution is doing so that we are getting the right answer. What he actually is doing. Anybody please? He actually is doing. Anybody please reply? Am I audible to you? It's okay, Kaushik. It's counting the frequency and comparing the two value. If true, it replaced with the first value. Yes, that's this algorithm. How this algorithm is working. Okay, let me share the one line intuition actually what he is trying to do. That's it, what he is trying to do. Let me share with you people. Let me rub the board. Okay, I will rub the board later. This is the key idea. Please read this key idea and let me know, is this key idea is working, is this algorithm is working on this key idea or not. If you can relate that in your mind, that is the best thing you can do actually. And that is your job actually. That is, you need to be done in your whole life actually. If you want to be a software engineer and if you want to be work with top companies, then definitely you need to relate your idea. You need to generate this idea first and then you need to implement that idea. Okay, can you relate what he is saying in this statement with whatever we have done? Okay, let me explain you what he is saying. For every letter J except the first, we know that we have left the first, except the first, all the copies of J has been taken at the time we start processing. What he is saying that, see, okay, let me explain this point with one example. Let me clear the board. Okay, let me write here. Let's suppose, let me take another example, not this one, not this one. Let me take another example. Let's suppose I have some strings. I'm writing their frequency. Frequency of A is let's suppose 6. Frequency of B is 5. Frequency of C is 4. D is let's suppose okay 3. E 2. F 1. Okay, I'm writing the frequency. Frequency of A is repeating 6 times, B is repeating 5 times. Okay, if you will add all of them, that will be the length of the string. Okay, I just simply sort them according to their frequency. What this algorithm is doing is, see what this algorithm is doing. He is replacing A with B. How many B we have? 5B. He is replacing A with B. He is replacing A. He is processing A. He is replacing A original string with B. But we have 5B, so he will take 1B from one. He will take 1C also. He will take 1C also. Okay, so he will replace all the 6A, frequency of A is 6 with B and C. Okay, and after that what we are doing? Now we are replacing B. See, this is the important point. Now we are replacing B. To replace B, can we replace B with B itself? Now at this moment of time? No, we cannot. Why? We have already consumed B to replace A. See what he is doing. He have already consumed B when the turn of B comes to replace. Now this is B's turn to be get replaced in the original string. But this algorithm is very clever. What he is doing is that he has already replaced all the B with A. So we do not have any B now. So one thing is sure, now we will not replace B with B because we have already consumed that. This is what this algorithm is doing. See, to replace B, I will use 4C. I will use 4C and 1D. Okay. So C is consumed now. C is 0 now. After replacing all B, he is replacing C. He is replacing C. Can we replace C with C now? No, we cannot replace C with C. We do not left with C. C is 0 now. Why C is 0? Because we have replaced all the B with C. Already we have done. This is what he is saying. For every letter J, all the copy of J has already been taken when we start processing J. When we start processing J, when we start replacing B, we see that okay, we have already consumed it. We have already consumed the B. The similar here, we have already consumed C when we start processing C. We already consumed D when we start processing D, because we will replace C with D. Similarly, we replace D with E. So when the term of E will come, there will be no E. There will be no E because we have already replaced them with D. So one thing is sure, same character will not be replaced with same character because we have already consumed that. But except first character. In that case, I am not applying this. For that, actually, and at the end, what I am doing, whatever is left, I am replacing with A. Because I know that whatever will be left, that will not be A. Because A is up to here. A is up to here. Why A is up to here? A cannot reach here due to this condition. N by 2 condition. A cannot be infinite long. A cannot be infinite long. So this is the main logic, okay, on which this algorithm is working. Let's see, okay, what is the complexity of this algorithm. You people please help me. You people please help me to find out the complexity of these steps. What is the complexity of first step? I want to find out the frequency of every element. I want to find out the frequency, how many times a character is repeating in your input. So in how much time you can find out this? Please write in the chat. Please write in the chat. Please write in the chat how much time this step will take to execute. Anybody please. I want to find the frequency of each character. How many times A is repeating, how many times B is repeating, how many times C is repeating. So for that, anybody? Order of n, very good Kaushik, that is order of n, because I need to process each character one time only. I need to process each character one time only, and I can add the frequencies of every character then. So that will take order of n time. And to sort the letter in descending order according to their frequency, in the worst case that will take n log n time. In the worst case, let's suppose all letters are different, then for every letter actually, so that will take n log n time. Okay, and these two steps actually you can check out, these two steps will take order of n time. Why they are taking order of n time? Because to replace one character, that will take constant time. One character to replace one character, that will take constant time, and to replace n characters in the original string, that will take order of n time. Same reason as the previous, as I used the previous solution. So what is the total complexity? You can add order of n plus order of n log n plus order of n. Okay, so the complexity is order of n log n. For this solution also, complexity is n log n. The complexity of second solution was also n log n. Here also the complexity is n log n. Let's move on. Let's move to a fourth solution. We have one more solution for the same problem. This is very easy actually, and we are going to wind up. According to this solution, we are going to change some minor change. We are going to perform some minor change in solution 2 and solution 3. We can improve them. How we can improve them? If we use counting sort, maybe you know, okay, what is the complexity? What is the worst case complexity of counting sort? Anybody? What is the complexity of counting sort? What is the complexity of counting sort? Counting sort is non-comparison based sorting algorithm. And we can apply counting sort here. Why we can apply? Because number of different letters actually can be only 26 here. The letters are fixed here. And if we have a cap over maximum size, okay, if we have cap, okay, we have different 26 letter maximum, so we can apply counting sort in that case. So we can apply counting sort in both solution 1 and solution 2 and solution 3, and the complexity of counting sort is order of n. The complexity of counting sort is order of n. So you can if you are applying counting sort, why we are able to apply counting sort? Because number of alphabets are fixed, 26 are there. So if number of alphabets are fixed, then this is the property of counting sort. We can apply this in that case. If you don't know about counting sort, please go through that. So if we are sorting the element, we are applying sorting here also, here also. Here I was taking n log n time. Here also I was taking n log n time. Due to that only my complexity was coming n log n. But now I am replacing the sorting algorithm. Rather than quick sort or merge sort, I am applying counting sort. I can apply counting sort for this particular problem. So the complexity will be, for both of them, will reduce to order of n. That will reduce to order of n. Simply I am sorting the element using counting sort. Okay. Okay, that's it for this session. If you want to go through the code, if you want to, okay, you want the code for all these different solutions. We discuss 4 different solutions here. I'm not sharing the code. If you want to discuss all these things line by line, one line of code, you want to understand in programming language, any programming language. Actually, you have to prefer C++ if you are going for competitive programming. That is faster as compared to Python. And if you want to that solution in line by line, you can join our course, competitive programming course by Joseph Amrit Raj, who is the grandmaster. He can explain everything in very crystal clear manner. Okay. And you can join this course, or the link of this course is given below. You can check out that, or you can check out GeeksforGeeks.org website. Otherwise, best of luck for the next Google Kickstart round. Please participate in that. At least solve first problem, 2 problems, 3 problems, 4 problems. Try every problem. At least try to solve first problem. That is the easiest one. And maybe you are applying brute force approach, apply that itself. But start taking participate in this if you're really looking for the Google. Okay, best of luck, and I'm stopping the session here itself. Okay, thank you.